Good morning, everyone. It's Mrs. Blanket-Beckler, and I am going to go over trig ratios with you today. So hopefully this will be nice, short, and sweet, and consolidate everything down to something really simple. Okay, we have three trig ratios that we're learning, and that's sine, cosine, and tangent. And we're going to set up these ratios in relation to this triangle over here. So to remember, we had a couple little acronyms we used in class. The first one was, some old hippie came a-hoppin' in my apartment. Or you can use SOHCAHTOA, which I kind of think of that as the Indian words. So I'm going to do SOHCAHTOA, which SOHCAHTOA is sine is SO, which is opposite over hypotenuse. So, or you can do some old hippie came CAHTOA is C over AH. Some old hippie came a-hoppin' through, T for through, our apartment or our alley. That's one of the ones on our PowerPoint today. So I'm going to set up my trig ratios using my little acronym, and let's go over to the triangle and set these up. Okay, when you do these trig ratios, you're always going to name them from the acute angles. You can never name a trig ratio from the right angle, because the opposite side of a right angle is the hypotenuse. So we're going to look at this triangle and set up in relation to angle A. Now, if you're having trouble with this at all, what you want to do is go to our reference angle, and notice all three of these trig ratios are from angle A. So what we're going to do is we're going to go over to angle A and figure out which side is the opposite, which side is the adjacent, and which side is the hypotenuse. Well, the easiest one to pick out is always the hypotenuse. So go ahead and label that first. Okay, our hypotenuse is always the longest side, is always opposite the right angle. So here is my hypotenuse. It's the side that is 10, which is my longest side. Okay, so from angle A, which side is my opposite side? So from angle A, I go across the triangle, and this side is my opposite. So what's left over has to be the adjacent, and that makes sense. Adjacent means next to, so which side is next to the angle? And it's the side that is 8. Okay, so I go ahead and label all three sides. Then I just plug in my values. Since sine is the opposite over hypotenuse, well, that's going to be 6, because 6 is opposite angle A, hypotenuse is 10. So my trig ratio would be simply 6/10. Okay, my ratio for sine is adjacent over hypotenuse. Well, adjacent is 8, hypotenuse is 10. So that would be 8/10. Okay, and the last one, sine is opposite over adjacent. Well, opposite adjacent would be 6/8. So that's how you set up your trig ratios. Now, let's talk about how to find the angles now. I'm just going to pick one of these. It doesn't matter which one I pick, because I should get the same answer because we're using the same triangle. So for simplicity reasons, I'm just going to go ahead and use sine. Okay? Now, for the sine of A, it is equal to 6/10. So I'm just going to bring that down and take out this acronym right here, 6/10. Okay? Now, I'm working backwards to find this angle. So whenever you're doing a backwards problem, you're going to use your inverse button on your calculator. Now, this is the key with the calculator. You have to make sure your calculator is in the correct mode. I was in class the other day, and someone wasn't getting the right answer. So click your mode button and make sure you're in degrees and not radians. Okay? So that's the first thing you want to check on your calculator. Now, let's go ahead and show you how to work this problem. Since we're working backwards to find the missing angle, to key this in the calculator, you're going to do sine and the inverse, okay? Every calculator is a little bit different. I have a TI 83, so I'm going to hit my second function button, or the yellow button in the top left-hand corner, and then sine. And when it comes up on my screen, it will have sine to the -1, which means my inverse. Then I'm going to put, it automatically comes up with parentheses, and I'm going to put this ratio in 6/10. So 6 divided by 10. And I hit equal or enter, and voila, I get about 37 degrees. Okay? So, that's how you find the angle. Once you get this angle, it's really easy to find the other angle. We just subtract from 90. Because if we have a right triangle and 90 degrees is here, we have 90 left for the two acute angles. So if this angle is 37, this angle would be 53. And voila, we're done. We've solved the whole triangle. We have all three sides and all three angles. And that's what it means to solve the triangle, to find all the parts. Okay? The other piece of the puzzle, or the other extra thing you might want to remember when you're dealing with right triangles, if you are missing a side that you need, and you have two of the sides, what is something you can do to find that third side? Okay, I'll just give you a quick example. If I am trying to solve this triangle, and this side is 5, and this side is 8, and I need, and we'll call this angle A over here, and I am asked about the tangent of A. Okay, tangent of A is going to be opposite over adjacent. So I need both of my legs. Well, notice I only have one of my legs. I do have the hypotenuse. What do you do to find that missing side? What do we have in our toolbox? Our toolbox of tools is the Pythagorean theorem. You're going to use the Pythagorean theorem to solve for the missing side. So on a side note, I would go over here and do a squared plus the missing b squared equals c squared, right? So 5 squared plus b squared, because we don't know b, is equal to 8 squared. So 25 plus b squared equals 64. Subtract 25. And I end up with, let's see, 14, 9, 39. So b squared equals 39. So b is the square root of 39. It's not beautiful. It's not a nice answer, but that's okay. It's just the square root of 39. Now I can set up my trig ratio. It would be opposite 5 over adjacent, which is square root 39. And that would be my trig ratio. Okay? My pen's getting low, so let me try it in red. The red's not much better. But that is how I would set up that trig ratio. So remember, you always have extra tools in your toolbox. One of our extra tools is the Pythagorean theorem. When you're dealing with right triangles, know you can always use it to find missing sides. Not missing angles, missing sides. Okay, good luck. I'm here to help you.